Okay, hello everyone, it's Salar and we are in part 37 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I talked about context switch in a simple real-time operating system. And I said what's under the hood when an operating system switch context, okay? But as I said, in this part, I want to complete this operating system, okay? And I wanted to talk about other functions in this operating system. For example, I want to talk about create new thread, OS initialize, OS start, and OS delay. From previous part, you know what does this function do and this function. And I said you can implement systematic handler to do context switch in this way in assembly form, okay? So from previous part, you know what's under the hood when an operating system do context switch, but in this part I want to give you more information about my operating system. But from next part I will start to develop a real RTOS, a real-time operating system, a real-time operating system with more facilities and standard facilities, okay, that other operating systems have. Okay, but let's jump to our business. First, what is thread control block or TCB? Abbreviated form is TCB. TCB stands for thread control block. Thread control block or process as control block, TCB or PCB. What's thread control block? For each thread, you need to save some data and information in memory. Okay? So, we save these informations and data in thread control block. But what is thread control block? Thread control block is a struct, is a data structure in C. Is a struct. And for each thread, you have one of these structs. Okay? But let's see the member of this struct and inspect them and see what are they. So first, thread ID. For each thread, you need to have a unique number, and you can use this unique number to have access to each thread. Okay, is a unique number for each thread. After that, thread name. As I said, you can set a desired name for each thread or process. The operating system put this string in this member. The maximum size of this name is 32 characters. Okay, is the name for each thread. After that, thread state. What thread state? As I said, each thread has two states: ready or running. Okay, here in SimpleOS.h, in the header file, I have my thread control block. In this structure, there is a thread ID member, thread name, and thread state. The type of thread state is a user-defined type, is an enumeration type. In my simple operating system, each thread has two different states, running or ready. In more complicated operating system, there are more states. Okay, but in my simple operating system, I just have two states, running or ready, to do context switch. After that, as I said, for each thread, you need to have a stack space. For this stack space for each thread, you need to have thread stack top, thread stack limit, thread stack type. You can save this address in these members, and another member is thread stack pointer, is a so important member in this structure. As I said, in context switch, when you want to change the state of a thread from running to ready, you need to save the value of its stack pointer in a variable. Okay, as I said, you need to save the value in start sp. I said start sp is a variable in memory. Start sp is this member thread stack pointer. You need to save the value of stack pointer in this sorry, in this variable in current running thread. Okay, and use that for next running of this process. Okay, but the last member is thread function pointer. But what is thread function pointer and what's this member? Take a look at this process. As I said, for each thread you need to have a function, okay, an independent function. For the first time when you want to run a process function, you need to run this function from the start address of this function. Okay, so you need the start address of process function or thread function. For next run, the operating system save return address in stack, as I said in previous part. Okay, but for the first time you need to have a start address of this function. Okay, so OS needs address of first instruction in thread function because OS needs this address to jump to it the first time of running thread. The first time of running thread, you need to jump to the first address of process function. But how we can acquire this address? With pointer to function. Pointer to function is a topic in C programming. Let's describe that. What is a pointer to function? You may know what's pointer to function, but let's review that if you know. Assume that you have a function, multiply function, do A multiply by B. You have two arguments, A and B, and a return value, the result of A multiplied by B. Here, I have a variable defined. This definition is like function definition, okay? You have a name and you have some argument and you have return value. But because of this parenthesis and this star, here is a variable. Here is a pointer, okay? Pointer to a function. In this way, ampersand sign and name of this function, you can find first address of first instruction in this function, okay? Address of first instruction in this function is in this ampersand and this name, okay? You can put this address in this pointer, in this variable, and now you use this variable as a function name. So this is a variable, and the value of this variable is address of a function that has two integer arguments and its return value is integer. So you can put address of first instruction in this function in this variable, because in this function we have two integer arguments and return value is integer. Okay, so in this way we can find the first address of first instruction in a function. So you can find address of first instruction in this function in this way, ampersand and the name of this function, ampersand and the name of this function, and give that to operating system, and operating system puts this value in this variable. Okay, what's this variable? Let's just see another time here. As you can see, I have a type definition, okay? I have a user defined type here. Here is a type, okay? And if a variable, for example here, thread function pointer, had this type, it means that the value of this variable is a address of a function that has no argument and return value is void. For example, my processes has no argument and return value is void. So you can put address of this function in this variable. Okay, so I give you more information about this member in next slide. So we have an struct for each thread in my simple operating system, but there is another struct and it's related to operating system, and in this struct we have some information about operating system, not just a process or thread. First is an array of pointer, the maximum number, the size of this array is maximum number of threads, is the definition in my code. The maximum number of thread in my operating system, for example, is 2, and I have 2 processes in my operating system. Okay, is a array of pointer, and each cell in this array point to a thread control block. Okay, is a pointer and point to one thread control block. Okay, but after that we have current running thread address of TCB. Another time here is a pointer to thread control block for current running thread. For example, as I said in previous part, in this part, when you want to find the current running thread in OS data structure, you can find address of thread control block for running thread, current running thread, and from that you can find, for example, thread stack pointer. Okay, here is a data structure that is related to operating system. That's related to operating system. After that, as I said, you have a integer variable and is osStart timer value, and I said in each context switch, in every context switch, you can increase the value of this variable. As I said, when you have a systematic interrupt, you can increase the value of a variable in this function, and in this function the operating system increase the value of osStart timer in OS data structure, and by using of this variable you can measure the time, because every 1 millisecond operating system increase this value. Okay, so after that number of added thread, as the name implies, number of added thread. Okay, here is a simple data structure and it's here in my operating system. Some information about operating system, a list of all of threads, pointer to all of threads, current running thread, a variable to measure the time, and number of added threads. Okay, so after that, let's talk about create new thread function here. Create new thread function, and if you want to create new thread, you can use this function. Okay, but what does this function do? Here, first, allocate memory to thread control block. I said for each thread you need one of these structures, and you need to allocate a memory for this data structure. First, allocate memory to thread control block here. Here, with malloc, allocate memory to thread control block, and size of this block is size of thread control block type. Okay. After that, set a unique ID to thread. Number of added thread, because at the first time the value of this variable is 0, but before that, first you need to add this pointer to this array, okay, to thread list. Add this pointer to this array, okay, thread list. After that, put the value of number of added thread to thread ID, okay. This line means first the processor put value of number of added thread. At the first, this value is 0. Put 0 in thread ID. After that, do number of thread plus plus. Okay, so for the first time, put 0 in thread ID. After that, increase the value of number of added thread by 1. So now I have 1 added thread. Okay. After that, set a name for thread. Copy this string, copy this string, okay, with a string copy, okay, from this argument to this member, to thread control block, thread name. Set the name. After that, set the state of thread to ready. At the first time of creating a new thread, all of thread are in ready state. Okay, so set the state of thread to ready. Put ready in thread state. After that, put the start address of thread function in thread control block. You put a start, for example, for process 1, you put the start address of first instruction in this function, in this argument, okay, and this function put this argument function pointer to this member. Okay, now in this member you have the address of first instruction in process 1 function. Okay, after that, allocate a space to thread stack from heap memory. As I said, you can have the process stack space in heap memory in previous parts, okay, by this by these lines. Okay, first, if this value thread stack size is 0, set the thread stack size in default thread stack size, and default thread stack size in 1 kilobyte. If it's not 0, put this value in thread stack size, okay, and set thread stack limit and thread stack top. Okay, but these lines are so important in this function. Okay, let's describe them here. These lines is for initialize thread stack. In these lines, you this function to initialize the thread stack. Okay, but what we need to do, initialize thread stack. As I said in the previous part, when a thread is in ready state, you need to save this address in *sp. Okay, you need to save this address in thread stack pointer. Okay, and a new created thread is in ready state, so you need to put this address in thread stack pointer in TCB and thread stack pointer. Okay, assume that here is okay, here is process stack pointer for a new created thread. Okay, thread stack space for a new created thread. Okay, so and here is thread stack top. You have this value in TCB, okay, and here is some value in this stack. Okay, this address is thread stack top minus 64 because we have 16 word in this stack. Okay, so you need to save the value of thread stack top minus 64 in thread stack pointer, okay, in TCP. These values are no important, but these two values are so important. First, program status register in a stack, the value of program status register in a stack. The address of this value in a stack is thread stack top minus 4. You need to put this value in this address, a reset value, okay, a predefined value, because in PSR register, bit 24 shows you are in ARM state or thumb state. If this value is 0, you are in ARM state, the processor is in ARM state. If this value is 1, the processor is in sorry, is in thumb state. And because in Cortex M processor we just have thumb state, you need to put 1 in this bit, okay, in program status register. So you need to put this value in thread stack top minus 4. After that, return address. Here is so important. As I said, the processor uses this value to return to process, okay, but because at the first time of running a thread, I said at the first time of running, the operating system wants to run this process. The operating system wants to run this process from first address in memory, okay, from address of first its instruction to memory. Want to run this process from first address. So you need to put the value of start address of thread function in this address, okay. So here you need to put thread stack top minus 64 in thread stack pointer. You need to put this value in this address, thread stack top minus 4, and you need to put address of your function, start address of your function in this address in a stack, thread stack top minus 8. Now context switch can use this stack space and this address to do context switch, okay. Context switch, the operating system can use this information to do context switch. After that, OS initialize. OS initialize is a simple function. Let's describe that here. Here, do some variable initialization. For example, put null pointer in current running thread, put 0 to this counter, put 0 in number of added thread, and pre-initialize this list, thread list, okay. Here is a simple function, and before to creating a new thread, you must call this function, okay. First call OS initialize to do some initialization on variables. After that, create new threads. You can create new threads, okay. But next function, osStart, is an important function in my operating system, okay. To start the OS operating system, we need to run first process, okay. First process, for example, here in my example, process 1 is first process because added before process 2, okay. Here is first process, so you need to run first process, okay. And in thread list, here in thread list, in first cell in this list, you have a pointer to process 1 because it's added before process 2. So as I said, we need to run first process instead of context switch. Okay, instead of context switch. But what does context switch do to run a process? Is here. As I said, you have this address. Assume that here is process1 stack pointer when it's in ready state, and here is process1 stack space stack space when is in running state. Okay, first you need to change the state of this process to running. After that, do unstacking by yourself. Okay, first context switch, put this value here in, put this address in PSP, and do context switch and do unstacking. When the operating system and your processor do unstacking, this value will change to this value, PSP plus 64. Okay, when you are in running state, this value process stack pointer point to this address. So you need to put this value plus 64 in PSP to do unstacking. But the processor put return address in PC. Okay, put this value in PC. Processor does this work. Okay, so because first time in the stack, you have address of first instruction of your function. Instead of this work, you can run process1 for the first time by just calling its process thread function. So for osStart, where it's here, first change the state of first process to running, first process in located in this cell 0. After that, change the current running thread in OS data structure. Change current running thread to process1. Okay, here we have process1. First time current running thread is process1. After that, put thread stack pointer plus 64 of process1 to PSP. Okay, put thread stack pointer plus 64 to PSP. After that, config system tick timer, config this exception. After that, change the privilege level of processor to unprivileged and use a stack pointer. Okay, change bit 0 and bit 1 to 1, and after that jump to the process1 function. By this way, you have address of the function here. You can put this value in parentheses and put double parentheses in front of here. Now it's like to jump to this function. Okay, so after that, run process1 function for the first time. So after this, the OS is started. Let's debug this project and see the result. Let's debug the project. Oh, I have some problem. Why? I don't know. So let's run this code. Let's run until the OS start. Step into the OS start. Run until this line, and if you step into this function, you jump to process 1. So the operating system has been started. And from this time, after this time, context switch function and systematic handler do context switch for you. Okay, here, so easy. Stop that and back to the slide. We have another function in my operating system, and it's OS delay, to create delay in millisecond. Where is that? Here, OS delay. Here is a simple function, and you can use this value, OS tick timer value, to measure time and measure the delay, and use this value to measure the delay and create an OS delay function. Okay, here is a simple function, and you can find out what's this function. Okay, so here was all about my simple operating system. Okay, here is a simple operating system that just do context switch. From next part, I will start to develop a professional real-time operating system with more facilities. Thank you very much to see me, and see you soon in the next part.